Okay, let's dive straight into this explainer. Welcome to the Surgical Theater. Today, we are performing a high-stakes, absolute deep dive dissection of the Cambridge Mathematics Syllabus 9709. Now, if you've been around the block with A-level math, you already know that the difference between a B and an A star often comes down to one thing, and that is absolute precision. And listen, nothing, I mean nothing, requires more steady hands and clinical accuracy than mastering vectors. Specifically, we're looking at the vector equation of a line, r equals a plus lambda b. We are going to treat this session like a precision instrument. I am not just going to tell you the formula, you already know the formula. Instead, I am going to show you exactly what those senior examiners are actively looking for when they grade your paper. We are going to give you the exact tools you need to break down incredibly complex vector problems with absolute surgical accuracy. So, grab your notebooks, get focused, and let's get into it.
Our agenda today serves as your examiner's playbook. We're going to cover the challenge, the strategy reveal, the transformation, an interactive workshop, and finally, we'll wrap it up with the final system.
Act 1, the challenge. Let's start by dissecting the flawed approach.
Right, we are starting exactly where you don't want to be, right in the operating room with a real Cambridge Mathematics past paper question. To truly understand how to secure top marks, we first need to dissect the flawed approaches that literally attract the dreaded red pen from examiners. I want you to look closely at Alex's approach on the left side of your screen. When asked to find the vector equation of a line, Alex clearly panics. What we see here is a classic case of overloading the page with raw mathematical facts. We see scattered dot products that aren't asked for, completely random magnitude calculations, and disjointed coordinates floating in the margins. There is absolutely zero analytical framework here. It's a pure data dump, hoping the examiner will magically find the right answer in the mess. Now look over at Sam on the right. Sam's approach is the exact opposite of Alex's, but it is equally fatal. Sam rushes the procedure and completely misses the command word requirements. Sam just hastily subtracts two coordinates, slaps a lambda on the end of it, and calls it a day, completely ignoring the fundamental need for a position vector. Both of these habits, the data dump and the rushed procedure, often start way back in foundational syllabus codes like 0580 or 0606. And here's the harsh truth. If you bring those bad habits into the 9709 AS and A-level exams, you are setting yourself up for an absolute disaster. The Cambridge syllabus heavily emphasizes that top-performing students must exhibit a connected, conceptual understanding. Neither Alex nor Sam demonstrates this. They lack a theoretical architecture resting on precise definitions and causal relationships. They are just guessing, and examiners can smell guessing from a mile away.
Moving on to Act 2, the strategy reveal. It's time to decode the method mark.
Okay, so this is where we flip the script entirely. I am about to reveal the secret weapon of top-scoring candidates. It's called the method mark strategy. Look, you have to realize that Cambridge examiners actually want to give you marks. In advanced mathematics, marks are heavily awarded for the process, not just the final answer. To capture every single one of those method marks, we are going to apply the Peel framework to our mathematical reasoning. Yes, Peel, point, evidence, explanation, link. Now, you might be sitting there thinking, wait a minute, Peel is just for English or history essays, right? Absolutely not. Let's apply it directly to r equals a plus lambda b. Your point is establishing your knowns, clearly identifying your position vector A, which is basically your ticket to get onto the line. Your evidence is calculating your direction vector B by explicitly showing the difference between two coordinate points on the paper. Don't do it in your head. Your explanation is your clear, step-by-step algebraic working, demonstrating how your scalar parameter lambda interacts with the vector. And finally, your link is bringing it all together into the final requested format, linking your mathematical working directly back to the specific context of the question. Top candidates use this exact framework to deconstruct the vector question, extract relevant data, select their analytical framework, and execute it with crystal clear notation.
Before we continue any further, I need you to do something crucial. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's put your brand new knowledge to the test. Take a really good look at candidates A and B on the screen right now. I'm going to give you a moment. Can you spot which one is actually applying the Peel framework? Notice how candidate B doesn't just vomit numbers onto the page. Instead, they clearly identify their assumptions right at the top. They physically show the step-by-step extraction of the direction vector. They provide a systematic, evidence-based progression to the final equation. Look really closely at how they handle that scalar parameter, lambda. They explicitly defined it, and then they actually verified their results. Candidate B communicates a logical, bulletproof mathematical argument. They are identifying limitations and alternative interpretations based on our systematic framework, whereas candidate A is just crossing their fingers. This is exactly what the examiners are looking for.
Act 3. The transformation. Let's take you from red pen to green checkmarks.
Let's see how this all builds into what we call the mathematics success blueprint. We are going to take Alex and Sam's flawed answers from earlier, and we are going to rewrite them mentally right now with surgical guidance. The absolute crucial point here is systematically applying this standardized 5-step sequence. Let's walk through it together. Step 1. Deconstruct the question. When the paper asks for the vector equation of a line passing through points A and B, we break that down. We know we need a starting point, and we know we need a direction. Step 2. Extract relevant data. We pull the coordinates for A and B completely out of the word problem. Let's use A as our position vector, our lowercase a. Step 3. Select the analytical framework. We state clearly on the paper, R equals A plus lambda B. Let the examiner know what tool you are using. Step 4. Execute with notation. Now, this is exactly where Sam failed earlier. We must carefully calculate the direction vector B by subtracting the position vector of A from the position vector of B. We explicitly show the working. We do not skip steps. We use proper vector brackets. Step 5. Present with terminology. We write out the final equation, clearly distinguishing between the vector components and the scalar parameter lambda. By deliberately applying these precise definitions and causal relationships, we've just transformed a messy, confusing page of scribbles into a top-tier, maximum mark answer. We've literally gone from red ink to green check marks just by following this system.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Act 4. The Interactive Workshop. It's time to deconstruct, solve, and evaluate.
Okay, grab your scalpel, because it is time to get hands-on. Problem-solving in vectors requires a relentless deconstruct, solve, and evaluate mindset. Challenge 1 is the data scan. I want you to look at the trends across these 3 complex exam scenarios, outlining position vectors, direction vectors, and scalar parameters. Imagine a 60-second timer ticking down right now. How does the position vector A change across these scenarios? Look at how the magnitude of the direction vector B influences the entire line. Ask yourself, are these lines parallel? Are they skew? Do they intersect? The Cambridge exam syllabus demands that you exhibit a connected understanding that transfers instantly to unfamiliar contexts. You shouldn't just see a grid of numbers here. You should visualize lines operating and interacting in 3-dimensional space. Evaluating this kind of evidence requires identifying limitations and alternative interpretations in a split second. This is exactly the kind of higher-order assessment objective you are going to face when you sit down for paper 3. If you can't read the data table, you can't build the equation.
Move into challenge 2, find the flaw. I want you to read this massive warning straight from the principal examiner report. Quote, "Candidates consistently confuse key terminology in cause/effect in vectors. Always define terms before using them." End quote. So what does this actually mean in practice for you? It means thousands of students every single year are fundamentally confusing a coordinate point, which is just a fixed position in space, with a direction vector, which is a movement, a trajectory, a path. That is a complete failure to understand cause and effect. The cause, the movement, is the direction vector multiplied by your lambda. The effect of that movement is arriving at a brand new coordinate point on the line. If you mistakenly plug a direction vector into the A slot of R equals A plus lambda B, the examiner immediately knows you do not grasp the underlying geometric principles. You must always verify your results, check your inputs, and ensure you are using the correct professional terminology every single time.
And that leads us to challenge 3, speed writing. I want you to ask yourself honestly right now, could you write one perfect, evaluative peel paragraph justifying why you chose a specific position vector over another in a hypothetical intersection problem? Your written paragraph needs to actively demonstrate evaluative thinking. You have to question the assumptions given in the prompt. You have to compare the mathematical approaches. If you choose line 1's position vector over line 2's to start your proof, you have to justify it with mathematical evidence. Remember, the higher-order Cambridge objectives demand evaluation of alternatives and justified recommendations. If you can clearly articulate that justification in writing, then you have truly mastered the theoretical architecture of vectors. Act 5, the final system. Let's talk about avoiding the fatal traps.
Synthesizing all this theory and practice into a bulletproof system is what guarantees top marks, and more importantly, it helps you avoid the most dangerous traps set by the examiners. When we dive deep and analyze the principal examiner reports, we find exactly 3 fatal mistakes that candidates make year after year without fail. Number 1, confusing cause and effect, which we just discussed at length, mixing up fixed points and direction movements. Number 2, forgetting to check your presentation formats. Look, the question might explicitly ask for column vectors, but you blindly provide IJK notation out of habit. Or even worse, you leave your final answer as a messy, unsimplified fraction instead of cleaning it up. Practical application develops professional skills, and applying the explicitly requested format is absolutely non-negotiable for that final mark. Number 3, giving answers that are not specific to the context given. Let me give you an example. If the question asks if 2 flight paths intersect, don't just solve for your parameters lambda and mu, find that they equal each other and stop. You must explicitly state in plain English whether the planes will crash based on your mathematical evidence. You must literally link it back to the real-world context of the problem.
To guarantee your top mark, your A star, and to completely bypass those traps, you simply need to rely on these 3 rules. First, command word decoding. If the paper says show that, you absolutely cannot skip intermediate steps. If it says evaluate, you must provide a final mathematical judgment. Second, peel framework application. Always structure your working with point, evidence, explanation, and link. Make it physically impossible for the examiner to lose your train of thought as they read down the page. Third, the time management matrix. Deconstruct the question quickly, but execute the notation carefully. Don't rush the subtraction of coordinates like our friend Sam did earlier. Systematic processing is your best friend under intense exam pressure.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Because at the end of the day, we dissected the anatomy of a perfect vector answer today, from the theoretical foundations all the way to the precise execution of the vector equation of a line. But the real question you need to ask yourself before walking into that exam hall is this: are you just memorizing disconnected mathematical facts? Or are you building an airtight analytical argument? Because the difference between those 2 approaches is the exact difference between simply surviving the paper and completely dominating it. Until next time, keep analyzing.